Hi, boys and girls. I hope everyone is enjoying their half day. What your math teachers and I would like to do today is to introduce our next topic, which is going to be in and out tables, also known as What's My Rule? Today we're going to look at a few input and output tables and try to determine what the rule is. The rules have to do with our operations: addition, subtraction, multiplication, and division. A couple tips to keep in mind. I'm going to make a note at the top of my paper. So I write tips because I always like helpful hints and tips. Is that if the numbers go up, you are dealing with either multiplication or addition. All right, so if they go in and come out a higher number, you're probably dealing with multiplication or addition. If the numbers go in high and come down lower, it's either subtraction or division. All right, so you need to look for those helpful hints. As we go on in input and output tables, sometimes you may have more than one function. Okay, you may have to multiply, then subtract, or multiply, and then add. We'll get to that later on. We want to do a couple of examples with you to show the functions and how they go in and come out in the input-output table. All right, so the first thing I'm going to look at is the number that went in. And if you notice, there's a variable up here, and the variable that we're using here is y. So I'm going to go down to my rule and determine what is happening to y. Later on, I'll be putting in multiplication, addition, subtraction, or division. All right, so I make some notes to myself. The number went in as 4 and came out as 11. So the number went up. So I want to think about either multiplication or addition. Now, I know my math facts, and I know that nothing times 4 is going to get me 11. So I'm going to think about addition. So I need to ask myself, what plus 4 will get me 11? And I know that 4 plus 7 equals 11. Now I don't want to put that as my rule yet to make sure it is true for every other in and out on this table, because they all have to have the same rule. So I'm going to check with 8. Is 8 plus 7 15? I know that 8 plus 7 is 15, so that's still true. We have a blank right here, 10, and I have to figure out what the out is. But I'm not going to do that yet because I want to make sure on my last in and out that the rule is still plus 7. So I'm going to ask myself, is 13 plus 7 20? And it is. So I know that I can apply that rule to going in as 10, and what will it come out as? So I'm going to use that rule, 10 plus 7, and I get my out of 17. Now I'm going to write my rule down and at the bottom to determine what the rule is. I have my variable of y, which represents the in numbers. Okay? So my rule here is y plus 7. That variable stands for a number. So I could put any number in and using this rule, get my out. Right now what you can do is, why don't you put in a number in the in, apply the rule, and tell us what you'll get as the out. All right, moving on to my second table. You notice here, my variable for the in is x. So I'm going to write down my rule right down there. Okay. Next, I have to see what happens to my number. 25 goes down and comes out as 19. So I know from my tips that at the top, the number went down, so I want to think about subtraction or division. Now I'm going to ask myself, can I think of anything that when I subtract or divide by 25, I get 19? I can't think of anything that I would divide by, so I'm going to think about subtraction. So 25 minus what will get me 19? Take a minute and see if you think you know what it is. You can also go off to the side and make little notes to yourself, 25 minus 19, to see what we get. I can't take 9 from 5, so I have to borrow. The 2 becomes a 1. 5 becomes 15. 15 minus 9 is 6. And 1 minus 1 is 0. So I have right here minus 6. Let's see if the rule works for the other numbers in this in and out table. I have 48 and 42. So in is 48, out is 42. Let's subtract those. Can I take 2 from 8? I'm sorry. I can, so I don't have to do any borrowing or regrouping. So 8 minus 2 is 6, and 4 minus 4 is 0. So it looks like we're on the right track. So let's put in that note to ourselves that we have minus 6. Checking it again, need to make sure what we have right there. I have next, I have in is 72, out is 6. I'm going to use the margin over here. 72 goes in as 72, comes out as 66. Let's make sure my rule still applies. The difference between 72 and 66. Can't take 6 from 2. And borrow. This becomes a 6. 12. 12 minus 6 is 6. So once again, I have a rule of minus 6. So right now, what we'd like you to do is, if it goes in as 90, we apply our rule as minus 6. What will our out be? So take a minute to apply that rule and find your out. When you're done with that, let's make a note of our rule is x, because that's our variable for the in, minus 6. Okay, so now we're going to move on to 2 more in and out tables. I'm going to change this. All right. So these are my next in and out tables. So far we've seen addition and subtraction. So you probably know we're going to have some multiplication and division so we can see all 4 functions. All right, my number comes in as 4. The variable representing the in is m. Goes in as in as 4 and out as 12. I noticed my number got bigger. So I don't remember my tips. It's either addition or multiplication. In as 7, out as 21. So again, number is getting bigger. So let's check. First I'm going to check what plus 4 will get me 12. I know that 4 plus 8 is going to equal 12. Let's see if that rule works for 7, because they all have to have the same rule. So 7 plus 8, that's 15, not 21. So I know my rule is not plus 8. So I can kind of cross that out. Process of elimination, trial and error. So next I'm going to ask myself, 4 times what equals 12? Now also keep in mind, if you get stuck, if you can't think of a function, you can always go backwards. So you take the opposite. We talked about reciprocals, flip-flop, go backwards. 12 divided by what will get me 4? So I know that 12 divided by 3 is 4. So 4 times 3 will be 12. So let's try and see if that rule works for the next couple of in and outs. So I'm going to use the same rule, 7 times 3, and it is 21. You guys will fill this in a moment, as long as my rule still applies to times 3. Let's try 12. 12 times 3 equals 36. So it looks like our rule is m, because that's our variable for the in, times 3. So why don't you guys now write down, if my in was 9 and I apply the rule of m times 3, what will my out be? Great, good job. Let's go to our last table for our last example. I have an in and my variable is s and my out. My first in, that's our blank, that's our out. We're not sure what that is yet. So I want to think about 18 to 6. The number goes down. So when I think about our tips, it's either subtraction or division. I'm going to first ask myself, 18 minus what will get me 6? So I can even do some 18 minus 6, and the difference there is 12. So I can try 18 minus 12. We'll do 18 minus 12. Is 6. Okay. So maybe it could be, my rule could be minus 12. Let's try it with 36. So off to the side, 36 minus 12. And 6 minus 2 is 4. 3 minus 1 is 2. So it went in as 36, and when I minus 12, I didn't get 24. So those don't match up. So my rule can't be subtracting 12. So let's think of another rule. It goes down, so my other option is division. So I can either ask myself 18 divided by what will get me 6, or 6 times what will get me 18. It can help you either way. And I know that 6 times 3 is 18, so 18 divided by 3 is going to be 6. Let's try this rule with 36. 36 divided by 3 is 12. And 15 divided by 3 is 5. So my rule here is s, because that's our variable for the in, divided by 3. So how about you tell us, applying this rule to 6 going in, what will our out be? Tomorrow we'll talk more about in and out tables. All right, what is my rule? These are also known as function tables. And I think you guys are going to be very, very strong in this area. And we're also going to talk about if there are more than one function, more than one operation. So thank you very much for watching. Enjoy your half day, and we will see you tomorrow.